Hello, receiving students, receiving teachers, and 7Es.
Hello, Miss Philip.
Thank you. You may be seated. Okay, open to the exercises that you did in your previous lesson. If you can still remember, I said we are going to go through the correction before we go on to our lesson for today. So I would like 4 volunteers, 2 boys and 2 girls, to come up and show their working out to those 4 exercises, 1A and B, 2A and B. So to the receiving teacher, you can also select 4 students to come up front and show the working out using the rules that were taught in our previous lesson. So 7Es, can we have 4 volunteers? On the whiteboard, I have 1A, B, 2A, B. So I'd like you to show the formula and also the figures substituting into those formulas that you are going to be using in your calculation. So 7Es, can we have a boy and a girl for the first exercise? Okay, Shannon, I'd like you to do 1A. 1B, can we have a girl? Because some of us are just sitting back. Quickly. Evelyn, 1B. Thank you. Next 2 for 2A and B, you stand by. Quickly. No, use this one. Make sure to write out your numbers clearly on the whiteboard, big and clear. You others sitting down, you cross-check your answers with our friends from the whiteboard. You others check your answers. The first one has been written on the whiteboard. Okay, can we have the other 2, and then we are going to go through the answers together. Michaelin, 2A. Can we have a boy? Jubilee, 2B. Quickly. You others check your answers. Okay, thank you to those 4 students. I'd like everyone to look up now on the board. We are going to go through the corrections together because there are some areas that we need to highlight in order for us to remember when we are showing our working out on the whiteboard. So have a look at 1A. Is he correct in using this formula? C is equals to pi d. Yes or no? Yes, but there is something wrong with this formula here. Is it really necessary for us to use capital letter D? No. So we should be using a small letter d. So correction here. Okay, small letter d. Your equal sign should be in line. So here we have 3.14. Is this a multiplication sign? Okay, when you are dealing with algebra, this can also be a pronumeral of x. So your multiplication sign should be written as a normal x. So correction here. Okay, your final answer, you should have, after multiplying these 2 numbers, you should have 15.7 centimeters. Put your hand up if you've got this answer. Very good. To those who got it wrong, make correction here. Let's have a look at B. C is equals to pi d. Formula is correct. How about this equal sign here? Are they in line with the first one? No. What must we do? We move all these equal signs so that they come in line with this equal sign here. Is that clear? The equal sign here should be in line with the one that you have written at the top. 3.14, the diameter is 8. 3.14. Is it the same as this one up here? Okay, your final answer should be the one down here. So this one will be removed. And you have 25.12 millimeters. Put your hand up if you have this correct. Okay, very good. Let's have a look at exercise 2. Here now the diagrams, as you can see, they're using C is equals to 2 pi r. R in this case because the radius is given. So you have 2 times 3.14 times 10. Very good. And your final answer should be 62.8 centimeter. Hands up 70s if you've got this correct. Okay, well done to those students who've got it correct. And the next one, C is equals to 2 pi, capital letter R or small letter r? Small letter r. Okay, always follow the formula that you were taught on. 2 times 3.14 times 2, the radius from the diagram is 2 centimeters. So you should have your final answer, 12.56 centimeters. So these are the answers from your previous exercises. Quickly make corrections to that. Okay, we will now move on to our lesson topic for today. Our lesson topic for today is solving problems involving circumference. Okay, circumference, we are still going to be dealing with curved surface or cylindrical objects. You already know what a circumference is. So when you are trying to look for a circumference, you are trying to work out the length that is going around a particular shape. Like for example, I have a circle shape here. The circumference is the curve that goes around the object itself. Also today you are going to be learning a formula on how to calculate a perimeter of a circle. So perimeter, as you have learned in your previous lesson, maybe in grade 6, you are to calculate all the lengths around or all the sides of a shape or object, adding all the sides of an object or shape. It is just the same as when you are calculating a circumference. So from the screen I have a definition. The circumference of a circle is its perimeter or the distance around the border. So if you have a square shape, when you want to find the perimeter, you are going to add all the measurement that is around this shape here. This is a rectangle shape. So if I want to find the perimeter, I'm adding all the lengths around or the measurement around this A4 paper. And it is the same as when you want to calculate the circumference of this or perimeter, you are trying to find out the perimeter of this sticky tape here, the circumference. Have a look at the formula that you are going to be using when we want to find the perimeter of a circumference. Perimeter is equals to half circle plus diameter. This is the formula that you have in your book. P is equals to half circle, you use pi d, plus d is the diameter. Pi d is the formula for circle. Are we following? Here in this case, they are using half. That is when a semicircle is given. So it depends on the different parts of a circle that is given. If I have, for example, okay, you have a shape like this. Can we say this is half? No, what can we say this? Okay, very good. This is a quarter. So that is one of your exercises in your books. But we are going to go through that together in order to help our friends out on the field. So exercise 1A, you have something like this. So we are going to go through the two learning activities from the screen first before we go through this one. So long as you have answered my question there, that is 1/4. Later I'm going to apply this together with the formula that we have on the PowerPoint. Okay, have a look at this example on the PowerPoint. Is it a full circle? No. Is it a quarter circle? No. What can we say? Okay, it is a half a circle. So the first formula that I have shown to you, we'll go back to that formula. P is equals to half pi d plus d. That is the formula that we are going to apply for this example. Okay, you look at it, it's got the diameter of how many? 20 what? 20 millimeters. Okay, look at it very carefully how it can be worked out. All eyes on the PowerPoint. Perimeter equals half circle plus diameter. Okay, this is the formula. This is how it can be worked out. P equals half circle, which is pi d plus d. Half pi times 20, that is the diameter, plus 20. Okay, the first calculation has been done here. 31.415 plus 20. Where did I take the 20 from? Okay, this is this 20 here. Can you see it is being separated by a different operational sign, which is plus. So order of operation, you deal with multiplication and division first, and then you go on to addition. So the final answer that we should have after adding these two, 51.4 millimeters to 1 decimal place. So you should have at least one number after that decimal point. So that is the answer to the first example. So I'm just trying to get you to see how the numbers or the formula can be applied to different parts of a circle. Now let's have a look at the second problem. Okay, you have example number 2. It looks a bit complicated here. You have a rectangle being drawn out from this heart-shaped diagram. But from this diagram here, what can you say 7 is? Shannon?
It's 20 centimeter.
So what does the 20 centimeter represent?
Half of the earth.
Half of the earth. Good try. Going back to the formula, what are we referring to with this measurement here? Can somebody help our friend? Tony? Any idea from you? The distance from this end to this end, or we can say the distance from this end to this end. What do we call this? Perimeter? Very good. It is called a diameter. What else can you see from this diagram here? Okay, you have a half a circle and also another half a circle here. So how many semicircles do we have there? 3. We have 1, 2, and 3. Always try to see the diagrams clearly and try to work out what is contained from the diagram. Okay, as you can see, this circle here will have a diameter of what? Who can tell us? From here to here, what would be the diameter of this semicircle? Shannon, again? You are saying an answer there?
20 centimeter.
Very good. This semicircle here would have a diameter of 20 centimeter. Can you see from this arrow here? It's the same length as this one from up here. How about these two? We know the semicircle here contains 20 centimeter as its diameter. How about the other two at the top? Okay, Emmanuel?
10 centimeter.
Okay, very good. Half of this 20 centimeter has been divided into these two semicircles here. This has a diameter of 10 centimeter and this has a diameter of 10 centimeters. So this is what our friend have just said. Okay, Shannon said the diameter of this would be 10 or 20? 20. The third semicircle? 20. So that is the diameter of this semicircle. This line represents the diameter. So don't forget, this line represents the diameter and not the perimeter. Unless you add all the measurements around this shape here, then you are trying to find the perimeter of the shape. Okay, let's have a look at how it can be calculated. P is equals to 2. What does this 2 represent? 7 is. We just went through the diagram together. What does the 2 outside the bracket represent? Ruthie?
Diameter.
Diameter, good try, but I'm still looking for another part to the answer. It is referring to the diagram. I'm giving you a clue here. Okay, let's have our friend there. Daryl?
Perimeter.
Perimeter. I have my P outside here that represents the perimeter, but I'm asking for this 2 here. What does that 2 represent? Isaac?
20 centimeter.
20 centimeter. Does this look like a 20 centimeter? Okay, it's a 2 here. Don't force it to be a 20. Should I tell you where I got this 2 from? Come on, 7 we are not thinking. Okay, these 2, are we listening? These 2 is taken from this diagram here. We have the 2 semicircles. So instead of repeating the formula over and over, we have the 2 outside the bracket. So as you can see, half pi d1 represents the 2 semicircles that were sharing the diameter of 10 centimeter each. So we're following. So I had my 2 outside plus, this is the formula for the third semicircle which had a diameter of, what was the other diameter of the semicircle? 20. That's why I had it as D2. These 2 circles, semicircle comes in this diameter here, which is 10. Okay, we have this formula that we'll be using in this calculation of that example. So we are going to simplify this in order to have at least simple figures to deal with. So I'm going to simplify 2 and 2 so they cancel out. 2 into 2 goes 1 and 2 into 2 goes 1. So these 2 numbers cancel out. You are left with pi d1. 1 times pi d1 is equals to pi d1 plus, we bring this formula down. It remains the same. Now we are going to substitute into these 2 formulas. Are we following 7 is? Okay, if you have any question, you can ask. Don't sit back and just follow through. We will now substitute into these 2 formulas. Remember, we have already canceled out these 2. So we have these 2 figures now or formula to use. Pi times 10. We are left with this formula here. Plus 1 divided by 2 in decimal would be 0.5 times pi, the figure is 3.14 times 20. You should have an answer of 62.8 centimeters to 1 decimal place. Okay, for our activities for today, you have 3 exercises to complete, and these are the formulas that you will be using to calculate the 3 exercises. For 1A, you will be using this formula. P is equals to a quarter pi d plus d. You'll be using this formula because the shape is drawn as a quarter part of a circle. That is for 1A. For 1B, you will be using this formula. P is equals to half pi d plus d because the shape is drawn in the form of a semicircle. For exercise C or 1C, you will have to be very careful because there are 2 different shapes in one diagram. So study it very carefully and use appropriate formulas required. You can either use P is equals to half pi d plus d, or you can use P is equals to a quarter pi d plus d. So I encourage you to look at that diagram very carefully and try to figure out what is contained in that particular diagram, which shapes are contained in that diagram, and calculate it using the appropriate formulas that are required. You may start now. You can discuss within your own groups. We should be talking and discussing our answers or working out to this, and not talking unnecessarily.
It's 1 quarter pi times 8 plus 8, one more radius. Remember, we are trying to calculate that. So here we have to plus it by 8, I guess. That's it, okay? 1 quarter times 3.14. Or you can have it as pi times this one times 8 in bracket plus 16. So you do your normal, you work each other bracket first, or you can have it as 1 times 3.14 times 8, we divided by 4. You try that out. You can go as far as this point to 8. Okay, now you have multiplied 3.14 times 2. 3.14 times 2. What do you say? Okay, you round it off to 1 decimal place here because this one here, it's a recurring number. It will not stop. That's why they have it just as this one, very short, so that you can add it with this one here. Time you punch in the calculator, you will see that the number continues. It doesn't stop. That's why they decided to just have 3 numbers after the decimal point, and you have this 31.415 plus 20. Okay, they added this with this. They got rid of these 2 numbers, so they had it as 31.4 plus 20. So it is like 31.4. 20 is a whole number, 0. So they had it as 4.15 to 1 dp. One number after the decimal place. So when we working on this line, number 1 plus 2. So if it's 31.415, every carry example number can become after this. Okay, it is half times
1. Okay, if you are still confused, you need to see me straight after the lesson so that we can at least clear out the confusion that we have in our minds, especially to do with the formulas. We will still find time to go through it together in order for us to grasp the idea of using this formula in our lessons yet to come. So don't think that we are going to leave that behind. We will still go through it together. So we will now go through our summary points for today. 7Es and receiving students. We have our 2 summary points on the PowerPoint. The circumference of a circle is given by the formula C is equals to pi d, or C equals 2 pi r, where d is the diameter and r is the radius. Quickly copy that first summary point down. You should be very fast. Okay, the second summary point. The circumference of a circle is the perimeter of the circle around its border. But here we have it as the circumference of a circle is the perimeter of the circle. It's just the same meaning. Our key phrase for our lesson for today, circumference and perimeter. To the receiving teacher, our next lesson topic is on angles. These are the materials that you need to prepare before the next lesson. Cardboard, thumb pin, or clock face. Okay, here up front, the cardboard and the thumb pins are going to be used to make different, or you can cut out your cardboard to form strips of paper like what I have in front of me. This is an example of a revolution angle that you are going to be using when you are trying to name the different angles in our next lesson. So you are going to have 2 strips of paper being pinned together using a thumb pin to form the different angles. So here in front I have a reflex angle. I have a straight angle from this angle to this angle. You have a right angle from here up. This is a right angle. Acute angle will look something like this. Obtuse, this is an obtuse angle. And the last one, you should have a reflex angle. It comes right around from this strip of paper and strip of paper right around to this end. And this forms a reflex angle. So 7 is, you are also asked to prepare such materials like this so that you are going to be using in your next lesson. With that, 7Es and receiving students and teachers, thank you for your participation in our lesson for today.
You are welcome.